Okay, this should now be live. I don't know if you can see the title of this at all, but today we are going to be building a 1/28th scale winch from parts I've ordered and parts I have laying around. So let's dive right into it. I managed to pick up this little N20 motor, geared motor. It's going to be one of those focusing issues again, isn't it? Yeah, there's my webcam, cool. I've moved everything around. My desk is slightly messy while I'm reorganizing the parts, so hence why I'm recording from the PC. But here's the winch I'll be using. As you can see, it's not like the normal geared winches. It actually has a 90-degree bend here, which I thought would be kind of nice and a perfect fit for building a winch. There's no actual set plan today. As I said, I've just got a collection of parts, speed controllers, BECs, and I'm going to just basically work out how to turn that into a winch. And I figured people would find that interesting, so time will tell, but let's dive right into it. So there are a couple of things we need. One is the motor. Another is, funny enough, some string, and oh, there goes the light. I put the string down, and now I can't find it. Ah, there it is. So for the moment, we're going to use a ball of twine. This is just for wrapping bacon around meats and other things. I actually do want something thinner, but in the interim, that's actually going to work fine. I've got a whole lot of servo horns. I figure they're going to be useful because we don't want the string coming off the end here, so I'm going to adapt one of these to fit on the end. I've got some nice little rubber stoppers that look like they're from a servo. Turns out they slide perfectly on the end here, which is kind of nice. They still rotate a bit, but we might be able to do something with that. I might also mention that this has actually got a flat side to it, and we are going to want to tighten that down somewhere, so we'll work that out as it goes. I've got a servo, not because I'm planning to use a servo, but because these leads are pretty valuable, and because I'm not going to use a servo, I'll just cut this off and end up using that lead. What else do we have? Don't need that plastic case. I actually decapped the speed controller, which is here, just to try and make things a bit smaller. As you can see, this is just a really ultra tiny brushed ESC, relatively simple, and in fact, while I've got it, I'm just going to, actually let's use my nippers. Just going to take off this cable, because I don't actually plan on using this BEC, and it's a bit difficult because I actually ended up splitting the signal line and the power lines to two separate things, and this actually complicated the a lot of the wiring on my pink Hummer. I wasn't particularly happy with that, so let's put that aside there, hide that underneath the camera where you can't see it. Okay, cool. I'm pretty sure I did have a soldering iron here at one point. Is that? Yep, it's in my lap. Okay, there's that. And we will need that because soldering irons get hot, and we'll likely need one of these to clean the tip. Now I do have a lighter here because I've also got some heat shrink laying around, and I found that this heat shrink that happens to fit over this perfectly, and I'm pretty sure when I light this it's going to grasp onto there, so I might either tie some rope onto some of the twine string onto this, and having a look at it, it's probably going to be too large, or I might in actual fact use a heat shrink to lock it in place. So let's dive into it, I guess. So we need to check which servo horns fit. From memory, these larger ones, yeah, that one's there. I know that one, that big servo horn's as large as this one, and so we'll test this one. That slides on, it jiggles around a bit, so that might be a good candidate. I will have to cut it off, of course, as you can see it doesn't fully rotate. I would like a round one, but I might have to do a lot of filing to get that to work, and I'm not particularly in the mood to do that tonight. So then I've got these small ones, which I thought might be interesting. So I think if I go like that, they just hit the body, so I'll just probably have to line them up and nip them off. And then I can just drill out that hole in the middle. Now, one thing with this, let's rotate it, that, if I take the soldering iron, there's actually a little brass riser here, and I'm a bit concerned that things are going to get caught there. So I don't know if I want to have a little spacer here to try and prevent things catching, or if I just want to have it on that side. I think we might just do it on one side and then make it so I can pull this apart if need be and fix it. Now, from memory, this is a 250 RPM motor at 6 volts. The reason I picked this up was I also picked up, so this is an N20 motor. I also picked up some N30 motors, which are slightly longer and give a bit more torque. And they will be what I'm using on the rally truck, because those ones are 1000 and 2000 RPM. But I figured that I've got the space for a more powerful motor. I might as well use the extra torque from it. The rally truck's going to be significantly heavier. It's going to actually have active servo-driven suspension on all 4 corners, so it'll be able to rise and... Well, actually, let me just grab the frame. It'll actually be able to lift its each corner independently, so it'll be able to rotate side to side and back and forward. And the idea is that I'll be able to adjust the ride height beyond what the shocks do, and then just push a button to make it rise and lower. So pretty massive project. I've already checked that 2 servos fit side by side in the chassis here. And then the servo arms will go out at 90 degrees and they'll go up and down slightly. The servos themselves come 55 degrees, so I should just be able to adjust this all from the RC unit, but I'll also have some electronics on board to do active countering, so it will, if it's on a slope, it will actually tilt into that. But that's a later project. I've got a MicroPython board set aside for that if anyone's interested. The other reason why I'm using a MicroPython board is because I'm going to be running all my LEDs off that. And the board I've chosen has a Wi-Fi and Bluetooth chip in it, and it's very, very easy for me to whip up a web server on that. So you'll actually be able to hit it on your mobile phone and control the lights, I guess the light patterns from a web interface, and then trigger them via the RC unit. So you'll just be able to do the setup work via Wi-Fi and a web browser. I can even do it with a PC in front of me, and then trigger them as you're driving. And the best bit is it'll be able to hook into the steering and throttle, so the brake light should come on automatically, as well as the side-to-side indicators. So I'm looking forward to that. This rally truck's going to be something very, very special. And people have been asking me if I will build cars for them. I might offer parts of the rally truck for download for 3D printing and then sell them. But in terms of actually building, my time is very, very limited, and I charge a lot for it, so it's actually probably not cost effective for anyone to get me to build them their RC car. There's probably people with a lot more time on their hands that are more than willing to help out. So if you're one of those people that's looking to get something built or is offering to build something, put a message down in the comments so both parties can find each other. My chat's going off. So what we're going to do first is I've got a body for, a reamer for a polycarbonate bodies. And actually, so some of you might have noticed I didn't actually post a video on Friday like I normally did. And that's because I was working on the Kyosho Optima. And you can see the sparkle there, which is kind of nice. Actually, I should have upped my bit rate. That's fine. Yeah, so this is my first attempt at spray painting. I'll let the camera focus a bit. And I'm very happy with the results. The sparkles actually come up really, really nicely in the camera and in the back. So this was all just masked off, which I'm kind of happy with how it came out. And then I had some scratches internally, and I found these paint pens are absolutely magnificent. These are just, I think these are Japanese paint pens. But I noticed a couple of people were using it to put white on the tyres for the lettering. And so I picked up a whole bunch of different colours and then found that I scratched it internally and just put some red over it, and it hides all the scratches. So that was rather nice. And then I've got the, a bit hard to see, EB410 in a very, very similar colour pattern. There's not a lot of space here, so that's fun. Anyway, let's get on to building. That's what you're all here for, hopefully. It looks like I've actually got people watching for once, which is quite different to Twitch. So thanks to all of you, and I'm going to say that this experiment of streaming on YouTube rather than Twitch, is a success. So we're just going to ream out the center of this servo horn, just to the point where it goes over this pin here, and only just, like, I want it to actually be a fairly tight fit. This could be fairly time consuming as well, as I've found when I've had to do this type of work in the past. So I could open the floor to questions if people want me to answer anything on live chat, or don't. That's up to you. Because I can probably talk people's ears off at this point. I must admit, with the live streaming, it's a lot of effort, and I normally don't feel like doing it, but once I dive into it, it's so much nicer. Like, it's not that much, not as much effort as I always think it to be. Okay, a tiny bit more. This is coming along nicely. So this hole is actually reamed out rather quickly. Let's see if I can bring up another one for comparison. So they only look subtly different on the camera, but I can assure you it's like light and day in terms of getting it to fit on the end there. Oh yeah, I do have live chat up and running. Cool. Now I'm really hoping this isn't blurry. I noticed last time in my last recording I didn't have the bitrate high enough, and I don't think I can change it while I'm streaming. Oh, can I? Let's try and do something dodgy. Transform, files, scene collection tools. Oh no, I've got to change the profile, so I can't do that. That's fine. I'm using OBS for anyone who's interested, and not even the Streamlabs, just raw OBS. I'm actually a competent programmer and system administrator, and so I can deal with bugs, and I haven't had too many issues with it. Now that's interesting. I'm looking at the live preview, and it's showing what looks to be a static image. Let me just check my stream health. Excellent, no data. Yeah, okay, all good. I did some benchmarking in the ultra low latency, and low latency and normal mode. Normal mode, the latency is about 30 seconds from someone typing a message to me replying. Low latency is 25 seconds, and ultra low latency I think was like 10 seconds, so significantly worse than Twitch, but for what I'm doing, that's fine. So you can see now that that actually got on quite easily now, which is good. I have to decide which way I want this to go on, and I'm thinking I might actually put the bottom of the servo horn inwards, just so that if I put that on like that, in fact, let's do that now. Let's pull off some string, which I actually pre-measured earlier, and I'm going to cut off some extra, because I want some desk space, so there we go. What are we going to do here? We're going to put it over the top, and we are going to... Actually, I don't need that much. I can probably just eyeball it, so let's take off that much. And we just do a test fit, because I've got a lot of extra. And wow, that's almost level with the top, so that was a good eyeball estimate. But we're going to go back in even further. There we go. Okay, so why are we doing this? The reason why we're doing this is so we can put the string through it like that. And then we put that over like that, align it with a flat side. And we'll be cutting this off in a sec. Actually, probably one in the other direction, so it'll just make it easy to cut off. Now, I just realized this string is actually probably flammable, and I'm about to take a lighter to the heat shrink, so bear with me for a moment. This may get dangerous. Okay, it's looking pretty good. Trick is not to get the lighter too close. You don't want to light the heat shrink on fire, and it turns out that heat shrink is actually flammable. You just want the heat to to cause it to shrink. And I can see some smoke coming off that, so I know it's getting probably a tiny bit too close. Yeah, and I can smell it. So I'm just going to squeeze it down a bit, because I probably made it a bit too hot. And while I'm at it, I'm going to clean this up. Now this is string designed for cooking, and I thought that would be a disadvantage, but it turns out it is actually just an advantage because it's designed to go in the oven. Normally you would wet this. I could have wet it, but I didn't. Okay, so that looks to be holding it. I'm not going to provide too much resistance. I found I can't back drive that easily, which is probably a good thing for a winch. So I'll take this part here. As you can see, the white part should fit over the black part and only just, if I'm lucky. So let's push that on. Actually, it's not going to go in because I have to trim it first. Yeah, okay. So let's work out how I'm going to do that. So I'm going to let it calibrate itself. So I'm going to try and push it down a bit. There we go. Or not. I find with a lot of these scratch builds, working out how to hold things is half the battle. Okay. Done. Done. So we're actually using the body of the motor itself so we don't have alignment issues. We're just aligning it to what fits, basically. But that said, we're still going to have to take a couple of mil, or half a mil off with a file. Okay, so that fits. Yep. Now, I actually found out I had a whole bunch of files. So one of the things about organizing my tools, so I bought some new parts bins basically, and I've got some bigger units as well that I normally have underneath the camera with my new setup, and I'm gradually filling them up. But when I was doing that, I went through a whole of old boxes and I found modeling tool after modeling tool after modeling tool. So if you saw any of my previous streams and noted how many modeling tools I've got, I've now probably got double or even triple that. And it turns out I've got like 3 sets of files, for example, which is actually a good problem to have. So this is a diamond coated one. It cuts some things really, really well. Plastic is definitely not one of those. This one's a bit more of a core steel file, and it just, yeah, it cuts through plastics really quickly. So I'm going to use this one a bit, I think. So I'm just running it along the length and then rotating it so back and forward like that. And while I'm doing it, just also slowly tilting my hand just to get a bit of roundness into the corners. Actually, let's cheat. So let's take a couple of mils off just to make it a better fit anyway, and then just take the corners off. I can take 2 corners off at a time by going at 45 degrees along the surface like that, rather than like that. Got to be careful not to take too much. Not that it's a problem, it's just not going to look nearly as neat. Although I plan to hide this inside the body itself with just a small protrusion at the front. So I actually do want this to be somewhat removable or undoable, because I do want to replace the twine with some fishing wire or something like that down the track. Something a bit more robust that doesn't have a lot of, I've got some dust and dirt there. It doesn't have as much, well, that's not too bad. Some of it, sometimes you can get some stuff that's springy, and you don't necessarily want that in a winch. Okay, I'm just running it through, making sure it clears. And I've got some edges I need to take off, but that's about it. I think we've got it right pretty much first go. So I guess like the essence of scratch building stuff like this is, I had a rough idea in mind, and I'd been hunting for one of these motors for a while. I knew I wanted one of these to build a winch. There are a couple of missing pieces though. One of them was, this is a DC motor without a speed controller. So I have to convert between the radio and the speed controller somehow, which is where this ESC came in. Now this ESC I use for the Geko, and it had one of the traditional forward mounted versions of these. Because I swapped over to a new ESC, I had one of these spare, and I actually had a couple extra on order anyway. I decided to stock up on a bunch of DC, oh, that one can still go in the back, DC driver units, because they're just generally handy to have around. But because I had this one sitting like handy and it's tiny, which will become an issue in a minute when I show you how I mount it, it seemed like a pretty good fit. Okay, so that's on there now. So basically this end thing is just to prevent the string going off the end there. So nice and simple. I can't really back dry. Oh, there we, okay, it is rotating. I may have to glue this in at some point, I think. Yeah. Alright. For the moment, I just want to do a quick rotation test to make sure that works. And it does. Okay. Once we've got the electronics on, we can do a proper test. So I've decided to leave a little protrusion on the end. I don't know how I'm going to solve that. I could drill a hole in the plastic here and then put a grub screw in, and that might actually work. But I think we're fine for the moment. We'll have to see how it reacts under load. Okay, so let's clear that. Next, we're going to mount up this ESC. And unfortunately, it's bigger than the motor, so I can't align the edge because it actually sticks over, as you can see, like that. And then if I line it up to the top here like that, it sticks over. I could align it to the back edge here, but then it sticks over where the string goes, and I don't want it to catch. I could put it there. I think I basically want it to hang off the back there. So I do have a solution for that. Picked up a whole lot of 3M sticky pads. I bought, I think, about 100 of these because I keep on running out of sticky pads, would you believe? Amazing, I know, but it happens. I did order squares, but they only had the circles in stock, and that isn't actually too much of an issue because at the end of the day I'm going to be cutting them up anyway. I'm not going to cut it to size yet. It's easier just to stick that on like that and then trim the excess. So I think I really need the camera higher and pointing down more. I've had to make some compromises for this stream just because I wanted something quick and dirty and I didn't want to have to clean up all the work I've got currently to the side of me. I've been working on a couple of things, but I owe everyone a DRZ V1 and no, DRZ V2 and DRZ Super Skid review and a GLD review. But I'm not the best at reviews and I want to have a bit more time to think about it, so I just thought I'd get this one out the door because I did get notified that actually this is a funny story in itself. I got notified that my tiny 4x4 package is arriving. Now they put down Australia as a destination country and the courier company sent it to Austria. So it's taking a bit longer than I wanted for the rally truck, but that's fine. Like, it's going to take a while to build the body, and we'll get to that eventually. Okay, so this connects like that. That's actually not the best connection now that I think about it. Maybe I do actually want to use one of these in that case. Or better yet, do I just solder that up? You know what, I might actually just solder that on. Do I want to solder that on? Yes, no, I can always put it into reverse. Yep, we'll just do that. Okay, decision made. Now I'm going to cut and use the black. So this is a DC motor. and they operate in either direction. So the concept of red, black, or positive, negative, especially in the context of how I'm going to be using it, is kind of irrelevant. How do I want to do that? It's going to go like that. So I need cable to go from there to there. So I'm not going to be too worried about polarities or anything like that. And then I have to do that as well. So for that I am going to need the servo wire. How much am I going to want? Probably want about that much. Over the weekend I had to replace some Ethernet cables, so I actually picked up a proper wire stripper. I'm interested to see how well this works. Oh wow, that's brilliant. That was definitely worth it. So perfectly stripped wires. Very, very happy with that. I couldn't have asked for a better job there. Okay, so that's VCC grounds. I am still going to have to pull them apart, but that's fine. Let's grab some proper tweezers for that. There we go. This is very, very fiddly work, unfortunately. But you are going to see me do some soldering, so that will probably be of benefit to some people. Alright, so I've now just splayed that out like that. Now having a look at the ESC and the wiring there, that actually matches what's on the cable. You just have to make sure we get our colours right. So in this case, red and red are the same, brown and black are equivalent. And the reason why you might see red and brown is for colour blindness. How am I going to do that? Like that? Possibly. Do I want to go further in? I might go further in and then clip it. Oh, actually I might clip it now. Okay, so they're all now a lot shorter. Let's clear some space and do some soldering. Do I want? Yeah, I actually do want the smaller one. Now, I think I bought this solder 10, 15 years ago, and I'm still using it. But I do have a proper solder dispenser somewhere. Wash your hands after using solder. Some of them do contain lead, and you don't want long-term exposure to lead. Okay, so how are we going to do this? The big thing to worry about is this actually moving around, so I might cheat. There we go. That gives me some leverage. Now you'll see I use the Miniware stuff. I do like that it's portable. I've got like 3 of these soldering irons. I keep like 2 in go bags and 1 at home. I normally do use a power delivery one, but today I want to use my one with modded firmware on it. So I'll plug that in. Input voltage 6 volts. I'm going to use 400 degrees, which may seem like a lot, but I tend to find it means you're touching the work for less. You do get slightly hotter though, so 250. There we go. Now you can see I'm actually leaning on the pliers, so they're acting as a heatsink, but also keeping the job stable. There we go. So I've just created 3 baubles there of solder up here. that'll just make the reheating job a bit simpler. And then we will go ahead and pre-tin the wires. Now, I actually made a mistake. I soldered from the back towards the camera. I shouldn't have done that. I should bring the soldering iron back away from the previous solder, whereas before I was going into the joints I soldered, and there's a chance you might end up heating the work again, reheating your solder joints. So okay, so we're just tinning the wires. Get a bit of solder on them to make it easy to solder later. I actually have to be careful here. I can actually put too much heat on it, so might need to inject a bit of extra solder, but that's fine. There we go. The best trick I can really give when it comes to soldering is just keep everything clean. The cleaner you keep it, the better you'll be. And like, if you wear glasses, do it under good light. Regardless of whether or not you wear glasses, do it under good light. But wear glasses, get a magnifying glass thing. Even if you don't wear glasses, like, the easier you can make it on yourself, the more confident you'll be to do this sort of work. So, okay, just need to line the ends up. As you can see, my hand's actually shaking a bit. I do get the shakes on occasion, so this just goes to prove that you can actually do this if you have handshakes. There we go. Let it sit in place for a bit and cool down. Good. It's not the best solder joint, but it will do. I wanted a bit to cool it down, and then the final one. Spend a bit of extra time to make sure that's in the right place. The worst thing you can do is get a solder bridge where you actually join two pads. That's annoying and difficult to clean up, so a bit of extra work really pays off here. Now, I normally use a flat chisel soldering iron. Today I'm using a point, a really sharp pointy one. The advantage of that is I can maneuver the wires around a bit. So, as you can see there, it's goes down to like a pen-like tip. So I'm not going to call this the best solder job, but it works. And if I wiggle the wires, they stay in place. I'll probably put hot glue on that later. I've been doing that on more and more of my projects just because I tend to break solder joints otherwise. Sometimes I actually let the solder flow up into the wire. If the insulating wire is strong enough and heat resistant enough, this works out really well because it just actually keeps that to be a strong connection. The most likely point to break is actually the transition from the end of the insulation to the actual unsheathed wire. So anything you can do, like getting solder further into the insulation or putting super glue over the top of that. Oh, sorry, not super glue, hot glue. Never use super glue with electronics. Super glue conducts electricity, and you will burn out your motor. So this was at 400 degrees. Put it on the stand, otherwise you will touch it. And I've specifically got it in front of the camera because I'm working in this area, and I won't touch the tip there. So awesome. Let's dive on to the next part, which is probably going to be mounting up. Now I've got to work out how I want to mount this. I'm thinking I might have the leads go away, in which case I want to bend these pins on the top back over. Whoops. Now I realized one of the things I don't have is a pair of pliers at the moment. They're around somewhere, I just can't remember where I've put them. So I just need to leverage them with this, and then I can bend them by hand. So now the pins are on the other side, and because it's all 90 degrees, that should line up like that. And then I can just bend back down. Maybe not. There we go. And then we'll splay them. So I'll just do a twist like that and splay them out. Make sure it's going down 90 degrees. So you can see the pins now going down. Put that onto the motor like that. And then we'll only have to run short wires to the actual terminals at the end here. Just going to splay that out a bit more. I think there's no reason not to. And it will make our soldering a bit easier if they're further away. So we check fitment. That's real close. Then we cut wire. And we tin wire, and then we cut more wire. Now I like this wire because it's actually got copper in it. It's actually remarkably good wire, which is kind of weird considering the product. It's easy to strip it with longer wire. So let me, actually because people might be interested, so you can see it clamps down on one side and then the cutting arm comes in second, clamps down on it, and then pulls it off like that. So we go, let me just line that up. Put the wire in like that. And you get a copper tip. Perfectly formed, and I normally do it with wire cutters, but I always end up with inconsistent results, which is a bit annoying. Sometimes I cut too much, which is what I'm really concerned about. So, one small wire there. One small wire there. This time we're going to use... Now actually, it's probably worth mentioning, these are really, really handy tweezers. They actually grip, which is really, really, really awesome. So means I don't have to apply any pressure to hold it, and it makes it a lot easier to work with. How am I going to do that? Do I want to solder that through that? Actually, you know what? Maybe I do. Maybe I'll actually solder to the motor first and then work out how I'm going to solder to the rest of it. So first I'm not going to tin it. It would be a mistake to tin it in this case because I've got to solder through very, very small holes. And if I tin it, I'm not going to be able to thread those, get the wire through those holes. So while I'm trying to get it through, I'm also rotating it, and that just makes it go through a bit easier. And then this is going to be an incredibly delicate soldering job. This is at 60 degrees, 100 degrees, 150. Not the fastest soldering iron, but you know what? If all you need is a USB battery pack and something that's almost like a pencil to be able to solder in the field, it's definitely worth it. I don't know how many of you would actually be soldering in the field, but I actually like not necessarily having to do it, but being able to do it. Okay, you can see I'm shaking really, really badly, and that's a lot of that comes down to hand position. So I've got enough solder on there now, so I can go back and just rest against the surface. And the reason I want to do that was that looked like a cold solder joint. So it's probably a bit hard to tell, but that's actually got a dull finish. So it's not the best solder joint, the shinier the solder joint, the better it is, but it will work, so I'm not too concerned about that. Now I'm going to leave that on and plugged into there, which is dangerous, but bear with me. And then we just twist the end to make sure that all the wires are together. And now we go in from the opposite direction and twist as I try and put it through the hole. And that's an alarm going off in my other room. And I could go fix that, but I'm just going to let the alarm run out. So we're back, we're going to clean the soldering iron. Keeping the soldering iron clean isn't going to solve all your problems, but it'll mean you will have less problems. Okay, it's not going well at all. I need to brace it against something. So cleanliness is definitely a factor when soldering. The other one is the correct temperature, especially with big metal parts like motors. And I've got an interesting story about that. You've got to make sure you've got enough temperature. Just because your soldering iron says 300 degrees or whatever, it doesn't mean that the joint you're soldering is actually at 300 degrees. It may be dissipating so much heat that the area you're trying to solder is actually significantly lower. And I tend to find that for most of the solder I use, the transition point is about 250 degrees Celsius. But you can buy solder that, how do I say it, does things at different, transitions from solid to liquid at different temperatures. So how do I want to do this? I'm not going to be able to, yeah, I'm going to have to do this manually. So what I do is I rotate the wire and just touch really, really lightly with the... Okay, that was a horrible, horrible, horrible mess. I've now exposed all the copper. Crap. How can I fix this? I guess it isn't too bad, but definitely not ideal. It is going to be a very, very painful solder job. So I'm going to twist those so the wires don't fray all over the place. And then I'm going to deal with that immediately. And I might even end up heat shrink. Oh, actually I will heat shrink the entire motor, I think. I don't have any conductivity issues. So now the question is, how am I going to hold everything together for the solder job? And the answer to that is, I am just going to stick it to its final location now. Peel that off. Work out where that's going to land. It's about there. And stick it on. Okay, that's good. And I can fold that back down against the wire I want to solder. And we're going to have multiple metals involved, which is not going to make this fun at all. So while copper solders to pretty quickly, aluminium, which is what these pins are, takes a bit more temperature and a bit more care in terms of cleanliness and that sort of thing. God, we're up to 44 minutes. Wow, this is taking a lot longer than I thought it would. Move that up. And we will use a soldering iron to try and lever everything into place. It's coming unfrayed. Right. So I'm going to run that to the side. So one of the problems with having wires exposed like this is, apart from accidentally touching them, is that it's very easy to have the wires fray off to the side, and like a single wire that can be microscopic and easy to miss can be going from one side to the other. And I've almost tried an ESC because of a stray wire that I'd cut off that flew across the room and then landed on the ESC and I didn't see it, and ended up shorting the power leads. Luckily, I managed to get it to work. It only blew up the power port, so the data port, so I couldn't reprogram it, but I'm not doing it with that RC car. I'm not reprogramming that RC car, so it was all good. So I want to finish this in the next 15 minutes because I want to cook dinner. So we're going to pre-tin the wire, which will keep everything together and make it a lot easier to deal with as a unit. Then we're going to pre-tin this aluminium leg. Which worked really, really well, so that's good. Then we're going to push the two against each other somehow. What am I going to use? I might have to use one of these. Or not, maybe I can just do that. So if you're dealing with multiple materials like I am here, so I did say aluminium and copper, if you pre-tin them with solder, the advantage you get with that is the solder to solder bond is significantly easier to melt than doing the mixed metal stuff, so it just makes the job a lot simpler. Okay. You know what, I'm almost tempted to do the exact same thing on this side as well. So if I have a look at this, so I'm going to do it in hard mode on this side and not pre-tin everything, but just go directly onto it. Okay, so that's touching. There we go. And then I will clean that up in a sec. And that's flowing really, that's flowing a lot nicer than I could ever hope for, so that's good. Remove that. Check that. Looks good. We now clean it with, oh yes, okay, so that's what I was saying earlier. My soldering iron is a Miniware. I've got nearly all their equipment. The quality from that manufacturer is incredible. So they definitely have expensive parts and they're definitely not the best, but in terms of portability, like I can take a full repair kit and diagnostic kit, including an oscilloscope, into a field, and it's just in a small box, about like no bigger than a mini Z RC car. Okay, so that's complete. Doesn't seem like it, but that is actually complete. I do have a servo tester now that we can use to test this. And this may catch on fire, so please, please, please have a fire thingy handy. And if it does catch on fire, just laugh because you're not here to actually put it out for me. So it wouldn't be the first time I've had something catch fire, especially when it's scratch building. Let's just put that over here as well. Okay, I'm going to call that a success. So let's so the speed is configurable because that's actually one of the nice things. Like, this is a really bad DC speed controller, but as a winch, it's almost perfect. I'm just trying to work out. I kind of want to see how far I can thread it on, so I need to provide some resistance to that, like that, and hold it like that. Oops. So it is actually coming off the end there, but there we go. That's it. If I put this over the edge, so actually let's just route it through the middle here and tie a quick and dirty knot. Well, actually, can I? Oh, come on, like that. Okay, and I'm going to chuck this over the side. And then bring it back up. Cool. Success. I have a mini winch. Now, it doesn't have some safeties. So when it's at max, when it's all the way in, or if it's all the way in, it doesn't cut off, so it will end up destroying itself, so you have to be careful. When it goes all the way out, once it hits that maximum, it'll actually spin, it'll start winding onto the other side. So that's fine, I don't have to worry about that case. And I just need to hot glue gun that. So thanks for joining me, all 9 of you. You don't know how much I appreciate that. And if you're watching this on YouTube, keep on building, and I hope you have great ideas, and have fun. Talk to you later. Bye.